Hi students, Mr. Courtney here. Today we're going to be talking about nuclear components under the unit of atomic structure. So we're going to start by defining an atom. An atom is the smallest particle of an element that can exist and still retain the properties of that element. Before, an atom was considered to be the smallest unit of matter, or it was said to be indivisible, meaning it could not have been divided into anything smaller. But later on, work was shown, or it was proven, or discovered rather, that there are smaller particles that exist within an atom, and these are called our subatomic particles, or protons, neutrons, and electrons. Protons have a charge, a positive charge. Neutrons don't have a charge. Electrons have a negative charge. So we can fill these in with our symbols. Protons are found in the nucleus. Let's put this down a bit, makes it easier for me to write. Found in the nucleus, so are the neutrons. If I will get my spelling correct. And these are found in the energy level. Anywhere outside the nucleus we will find these. Now let's talk about the mass here. And we should have put relative. So we talk about the relative mass. Sorry about that, I had a break. So the relative mass. Now if I tell you that protons and neutrons are approximately the same size, if I compare the mass of a proton to the mass of a neutron, since they're approximately the same size, the mass of a proton divided by the mass of a neutron will give us 1. Whereas with an electron, if I compare the mass of a proton to the mass of an electron, or neutron to electron, it gives us this 1 over 1840, which is approximately equal to 0. So that tells us the mass of an electron is negligible. It does not play a role or a significant role in the mass of an atom. So the atomic number Z is the same as the number of protons in the nucleus of an atom. It is also used to identify elements. So based on the number of protons an element has, or an atom has, we can identify it as being the atom of a particular element. So let's suppose it had 6 protons. That's an atomic number of 6, which gives us the element carbon. Now in a neutral atom, let us compare the number of protons and the number of electrons. Electrons have a negative charge, protons have a positive charge, and if the atom is neutral, the overall charge will be 0. So for the overall charge to be 0, protons must be equal to neutrons. Okay, so in a neutral atom, number of protons is equal to the number of electrons. Alright, so here we are on the mass number. Mass number is the sum of protons and neutrons. That is, what is the total number of protons and the total number of neutrons in the atom, or the nucleus of the atom, to be a bit more precise. Now, it is always going to be a whole number. So it's not going to be a decimal or a fraction. And it's important to remember that we do not find the mass number on the periodic table. So that means when I look on the periodic table, whatever number we're seeing that represents mass, it is not the mass number. So keep that in mind, okay? So if we look at the condensed form of writing the nuclide form of an element or an atom, E, the big E gives us the element. So whatever the element here we're talking about, the Z, remember that's our atomic number, and A is our mass number. In the top right hand corner we have the charge of the element, and we'll talk about that. How do we get a charge in a couple minutes? So let's look at an example of this. Now, for example, if we have the element magnesium, okay, so magnesium, we write the symbol Mg. Look on your periodic table, you see magnesium has an atomic number of 12 and would have a mass number of 24 and a charge of 0. Now, how do we know the charge is 0? Because we're not given any electrons, we're going to assume that the number of protons and electrons are equal. So it's in a neutral or a stable atom. Now, let's look at these pictures at the bottom here. First, we're going to have to identify what these elements are. See, look at the number of protons in these. Based on the number of protons, we can identify the element. This one has 1 proton, so the element is hydrogen. The second has 1, 2, 3 protons, so the element is lithium. Okay. The third one has 1, 2, so we know that element is helium. Now, let's write the atomic numbers in. Atomic number of 1, because we have 1 proton. Mass number is the sum of protons and neutrons. 1 proton here, 1 neutron. So that gives us a total mass of 2. 1, 2, 3, 4 neutrons with 1, 2, 3 electrons. So 3 and 7. 1, 2, 3, 4. So a total mass number of 4 and 2. So there you have it. That's how we've written the condensed form for these elements or these atoms. Now, another way we can write it, it's like this. You write the element name followed by a hyphen, then the mass number. So that means the first element can be written as hydrogen hyphen 2, lithium 7 for our second one, and helium 4 for the third one. Okay, so now let's talk about ions. Let's talk about charges. What is an ion? An ion is a charged atom. So an ion is a charged atom. So how does an atom become charged? How does it go from being stable to being charged? How does it go from having equal numbers of protons and electrons to having unequal number of electrons and protons? What happens? There we have it. So an atom becomes charged when it gains or loses electrons. So if we look at the number of protons to the number of electrons, we'll see that they're not equal. So if you have more positive, or let's say our protons are greater than electrons, then that means the charge will be positive. If electrons are greater than protons, the charge will be negative. Okay. Okay, so let's go ahead and fill in this table here now. We start with the isotope symbol. We're given the symbol of the isotope. So we start with the symbol. So we have Ne. Look on your periodic table. You see that corresponds to neon. Find the atomic number of neon, which is 10. This goes here. We're already given the mass number. So we're given the mass number. So we're going to fill this in right here. That is 22. The number of protons. Protons would be the same as the atomic number. So that gives us 10. Now remember that mass number. How do we remember how we calculate our mass number? Mass number is equal to protons plus neutrons. So that is P plus N. So if I want to find the number of neutrons, then I'm going to take the mass number and subtract the number of protons from it. So in this case, it would be 22 minus 10. That leaves us with 12. Now, since the number of protons is equal to the number of electrons, they have equal number of positive and negative charges, so that means our overall charge will be 0. So there's no charge because we have the same number of protons and same number of electrons. Positive charges equals negative charges. Overall charge will be 0. Okay, so if we look at the others now, an atomic number of 24 gives us the element chromium. So that's 24. We have the mass number of 52. So we need to find the number of protons. Protons is equal to atomic number, so that's 24. Again, to find the number of neutrons, 52 minus 24, that leaves us with 28. Now let's look at our charge. 24 protons, 22 electrons, so they're not equal. And if you look up here, we have more protons than electrons. When we have more protons than electrons, the overall charge is positive. So we know we're going to have a positive charge. But we have 2 more protons than electrons. We have 24 protons and 22 electrons. So that gives us a charge of plus 2. Okay, and the last one, protons. The number of protons would be equal to our atomic number. So the atomic number would be 35. 35 gives us element bromine right in here. Mass number is equal to what? Remember what mass number is? Protons plus neutrons. So that gives us 81. Here we have 35 protons, 36 electrons. So we have more electrons than protons, so that means our charge will be negative. But how many more protons than neutrons we have? Or sorry, how many more electrons than protons we have? We have 1. So we can leave it as negative, or we can put negative 1. Doesn't make a difference. Okay. Okay, so let's talk about isotopes. What are isotopes? And we're going to use these examples here to identify isotopes, what isotopes are, to come up with a definition of an isotope. All these are the elements, atoms of the element hydrogen. How do we know this? Well, one, we're given the symbol H, and look, they have the same number of protons, or the same atomic number. So that makes them the same element, because elements are identified based on the number of protons they have. But how are they different? They're different based on the number of what? Well, their mass number initially, but what makes their mass number different? That would be the number of neutrons. So the best way to define an isotope is an atom of the same element with different numbers of neutrons. Okay, so again, atoms of the same element with different numbers of neutrons. That's what an isotope is. Okay, so that takes us to the end of this section. You have some questions here that you can go ahead and answer. I'll do an example in each section so that you know exactly how to do it. Then you're going to take your time, go through it, pause the video, and then you can come back and look at the solutions. So in the first section, fill in the blanks. Remember, you're given the element name and the mass number. So to find the number of neutrons is the mass number minus your atomic number. That gives you 7. And remember, you find the atomic number on the periodic table. In the second section, you're given protons and neutrons. First, you need to identify the element. 80 protons, that's mercury, hyphen. Then you're going to add your protons and neutrons together. So that's 80 plus 121, that gives us 201. So mercury 201. In the last section, you want to write the nuclide form. That is, you want to write the symbol for the element, Li, atomic number, and then mass number, and then charge of 0. Okay, so go ahead and pause the video, work on them, take your time, and then come back and view the answers. Okay, so here are the solutions. Hope you got these correct. If you have any questions, you know where you can find me. There you have the solutions. So I hope this was helpful to you guys, especially for those of you who missed class, or you didn't grasp something in class. Oh, I forgot to put in 2 answers. 3 actually. This would be 2, 6, and 147. Okay. All right. Until the next time. Blessings.